It is quite rare to set up a material and have it turn out perfect the first time. Look development, like many aspects of computer graphics, is an iterative process. Everything we build should be aimed to make this iterative process easier. Katana is equipped with a lot of features that allows us to do just that. Let's look at an example. Set the edit flag on the Treehouse Network Material Create node. If we now need to change any of the parameters of the shader inside, we need to step inside this Network Material Create node, find the relevant node, and search for the parameter we want to edit. And we need to do this every single time we need to make a change. Katana allows you to promote any parameters on any of the nodes inside the Network Material Create node to be available to be edited in the parameter interface that you see here. This parameter interface is currently empty as we have no promoted parameters. So let's step inside the Network Material Create node and set the edit flag on the Pixar surface node. Let's start with the diffuse parameters. To promote the diffuse gain, for example, click on the wrench icon next to the parameter and choose Add to Material Interface. If we step outside the Network Material Create node and then set the edit flag on it, we can see that the diffuse gain has been added to the parameter interface. We can also see that the gain parameter shows up automatically in the diffuse page. This is controlled by the Material Interface options. Click on the wrench icon again and choose Edit Material Interface options. The label refers to the display name of the parameter you see here, and the page refers to the collapsible tab here. The name parameter is the actual name of the parameter itself. Do not confuse it with the label, which is used just as a meaningful display name that you see in the interface. When using this parameter in any expressions, we need to refer to the name parameter, not the label. In most cases, you don't need to change any of this, but as you will soon see, there might be cases where you want to display parameters on a specific page. So knowing how to edit this will become useful. Let's go back into the Network Material Create node and promote some more useful parameters. I'll fast forward through this bit as all I'm doing is selecting the Add to Material Interface option on every parameter that I need. And this is what I have so far. You can add as many parameters as you need to the parameter interface. Next, let's look at adding some extra parameters to the material interface. Step inside the Network Material Create node. Let's say that we want to easily change the diffuse file texture for the shader. I'll set the edit flag on the diffuse texture node and add the file name parameter to the material interface. If you step back out to inspect the material interface, you can see the file name parameter now appears in the parameter interface. However, it appears in a random location where it doesn't make much sense. Let's edit the material interface options and place it somewhere more appropriate. Since this is a diffuse texture, I'd like to place this inside the diffuse page. To do this, we just have to write diffuse in the page parameter and press OK. And as you can see, the file name has moved to the diffuse page. But I would now like to change the order of where the parameter appears on the diffuse page. To do this, switch to the Sources and Order tab, expand the diffuse page, and now middle click and drag the file name parameter to where you would like it to appear. I want this placed at the very top of the diffuse page. And if we now switch back to the Parameters tab, we can now see the file name parameter appear exactly where we placed it. Next, let's look at how we can override the properties of a material. As I mentioned earlier, the top house material group uses UDIM textures. Most of the geometry in the material group should have properties of wood, except for the antenna and the rope. But we will use the antenna as an example in this lesson. We could just create a new material just for the antenna, but this would just be extra work that's completely unnecessary. Let's launch a live render. This time I've included some extra geometry in the working set. No additional work was done to the material we set up in the last lesson. And all the geometry you see here is using the same material we worked on in the last lesson. I'm simply revealing what was hidden by the working set in the last lesson. I'll expand all the leaf locations of the treehouse location to reveal it in the viewer. And this time, I will right-click on the treehouse location and from the Pin menu, choose Pin Visible Leaves. Pinning a location makes it always visible in the viewer, even if we collapse the parent group, making it much easier to work with any given part of a scene. I'll zoom the camera more tightly on the antenna. And as we have included the camera in the Live Render Updates column, we are able to see this update interactively. And as you can see, even though the texture looks like it belongs to a metal object, the material properties don't seem to match up, as everything you see in the render is sharing a single material. Now, if you are thinking about editing the material directly, Remember that all the objects you see here also share the same material. We will look at directly editing the material location in the next lesson, but in this case, we want to override only the antenna geometry location. And to do that, we want to place a material override on just the specific location's material attributes. While this may sound complicated, recall that we learned in a previous lesson that any location is defined by the attributes that it holds. So how does that apply to materials? After all, the material we made lives in this location that we simply assigned to these geometry locations in the last lesson. Select the antenna location in the scene graph and switch over to the Attributes tab. You can see that there is a material assign attribute pointing to the location of our material. Left-click on the yellow icon and choose Show Attribute History. This interface will show any upstream nodes responsible for changing this material assign attribute. And in this case, we just have a single node here, which is the material assign we created in the last lesson. Left-click on the green arrow to open the parameters of that node. And as you can see, we now have the parameters of the material assign node. But what about the parameters of the shader itself? Recall that we learned about the deferred loading concept in an earlier lesson. No details of the shader is passed to this location until render time, making Katana very efficient in working with large datasets. It is the job of the resolver to fully evaluate all the attributes in any given location before render time. While there are ways to permanently resolve these attributes within Katana, we will not go through that in this course. Instead, let's click on the Implicit Resolvers Active button located in both these locations. You can click either of them as they do the same thing. And as you can see, if you expand the parameters page, you can find all the exposed shader parameters present here. This will temporarily show you the fully resolved state of all the attributes of a location. And keep in mind that you do not have to enable implicit resolvers to make any of these changes, but it will certainly make it easier to find the attributes we need to change. I want to change the refraction index and the extinction coefficient parameters of the shader. Let's switch back to the node graph and make some room for our material override, right below the material assign backdrop. I'll create a new backdrop and call this material overrides. There are several different ways to edit an attribute of a location, but for now, I'll use the material node to do this. Press Tab and create a material node and set the edit flag on it. In the Action drop-down menu, choose Override Materials. It is important to choose Override Material and not Edit Material here. The Edit Material option can be used to directly edit a material location, not a geometry location the material is assigned to. And to directly edit the material location, there are better options in most cases, like the Network Material Edit node, which we will look at in the next lesson. I'll change the name of the material override to MO_antenna. Select the antenna geometry location in the scene graph and click on Add Statements, Append Scene Graph Selection. We now need to specify the shader parameters that we want to override in the Attributes widget. Switch over to the Attributes tab and ensure that the implicit resolvers are active. I will middle-click and drag the edge color, refraction index, and extinction coefficient parameters into the widget area labeled as Drop Attributes here. You can obtain physically correct values for the refraction index and extinction coefficient from an online resource like refractiveindex.info. I am going to use the following parameters. And as you can see, the antenna is now better represented as a metallic object. If you disable implicit resolvers, you can see that our overrides are stored inside a material override attribute. The resolver is responsible for making a copy of the material at this location and applying our overrides. And you might have noticed that we have the override still visible in the render, even with the implicit resolvers disabled. Implicit resolvers, as the name suggests, are applied implicitly before render time, regardless of the active or disabled state of this button. Next, let's look at how to set up another material within the same Network Material Create node. Set the edit flag on the Network Material Create node. Click on the plus icon to add a new material, and choose Add Network Material. I'll call this NM_middlehouse. Step inside the Network Material Create node, and as you can see here, a second PRMan terminal is available here. While we can create many more materials inside the same Network Material Create node, I personally like to limit this to materials that tend to share the same textures or are closely related to the asset. It is even more important to organize the material node graphs as we add more materials within the same Network Material Create node. And Katana has several features that can help with this. Firstly, we can create a backdrop just like we did in the node graph. select all the shading nodes and press Tab, search for Backdrop, and press the Enter key. Let's call this backdrop Top House. We also have the option to collapse these nodes into shading groups. Select all the nodes and press the G key. Just like the group node we have seen before, these nodes are now placed inside a group, which you can control middle-click on to step inside. Shading groups can also be converted into a macro, which you can reuse with new or existing network material create nodes. I'm going to step out of the shading group and undo the change, as I like to just use a backdrop in this case. I'll now work on setting up the material for the middle house texture set. As this process is pretty much the same as before, I'll just fast forward through this. After assigning the material to the middle house geometry locations, I've added the same locations to my working set, and we can see the relevant geometry with the material in the render. I'll encourage you to practice setting up the rest of the materials for the remaining assets using what we learned over the last few lessons. You can ignore the tree group, as we will not be using that asset in this course. Or if you are comfortable enough doing this, you can use the recipe with the complete material setup that I've included with the course, in order to continue to the last stage of the material authoring process, baking look files. Once you have set up all the materials, or if you're using the included example file, your scene should look something like this. Let's assume that this is all approved to go to our good friends in the lighting department. Before they can start making the shot look beautiful, we need to pass on all of our work to them in an effective way. While we looked at solutions like live groups in earlier lessons, in a production environment with hundreds of assets, the most effective way to do this is via a look file, commonly referred to as KLF. It is important to know that a KLF can hold more than just the material and geometry assignments. You can use a KLF for anything from global render settings for the whole studio to custom light shaders set up with shading nodes that you can then load in the GAFA3 user interface. It is for this very reason that you want to be extremely careful of what you pass on to another department. For example, if you have increased the tessellation of a particular geometry to make your render look a bit nicer, you don't usually want to pass that information on to a lighting artist, as it can not only prove costly to render, but it can also be tricky to track down that change as someone who isn't aware that it exists. Let's take a look at our current setup to learn more about how we can ensure that we write clean data into our look files. And as you can see, I've clearly marked an area here where the material work should end, and any working changes that you make that is not desirable to be baked into a KLF exist underneath it. You can also see a backdrop labeled as Look File Bake that is just off to the left side of our node graph. Press Tab and search for Look File Bake. The Look File Bake node lets you bake your look development as a .klf file by comparing the scene graph difference at two chosen points in your node graph, before and after the material creation and assignment. Press Enter to select, and let's place this on the Look File Bake backdrop. Set the edit flag on the Look File Bake node, and let's take a closer look at the inputs available for this node. You can see an original input and a default input. The original input expects scene graph data in its original unmodified state. The default input needs to be provided scene graph data in its modified state, which means that we need to provide an input of a point in the node graph with all the changes we want to write to the look file. I'll connect the original input to the merge node, where we are merging the assets together, since that seems like the last point of input without any modifications to its data. The default input should be connected to the node that I have labeled Material Work Ends here. In the root location parameter, we need to provide a scene graph location where we want Katana to start searching for changes to data. Since all our materials are assigned to the location beneath the assets location, I am going to middle click and drag the assets location into the root location. In the Save To parameter, we need to specify a location on disk to save the look files to. Browse to a directory and save the look file as assets.klf. I'll leave everything else at its defaults. Now click on Write to Look File, and it complains that the hierarchy does not match. If we take a closer look at the node graph, we can see that we have a prune node right below where we merged the assets. Although I generally recommend pruning unwanted location as early as possible for optimizing performance, when it comes to look files, you should only be adding locations to the asset, not removing them like we did here. To fix this, I can move the prune node below the point where the material work ends and place it in the Assets Overrides backdrop. But in this case, since I know that these locations will never be used in lighting as well, I'm simply going to move the original input below the prune node. I'll also tidy up the look file inputs using the dot node. Let's click on Write Look Files again. And this time, it has successfully written out the look file. In the next lesson, we will learn how to use look files from a lighting perspective and also work on setting up the lighting to make everything look nice from the perspective of a lighting artist.